ETAB is a software used to perform to analysis and design in engineering. So first of all, to better understand the software, we will discuss applications and conceptual knowledge of basic component of building. So application of ETAB and engineering. Here I have some major parts where we can use the ETABs. So first we will discuss RCC. So here I have some RCC projects. This is my site photographs that is designed on the ETAB, and some finished project designed on the ETAB in RCC structure. Same second application is steel. So this is my steel structure, and the whole steel structure is designed in ISMB, and this is my purlins, and this is my truss members, main members, and this is my side photographs, and this is my finished steel structure project, analysis and design on ETAB. Now other one is the tower. So this is my tower, and here you can see this is my GSMs, and this is my microwave towers, and this is analysis on the ETABs. And next one is the water tank. So this is my water tank peak, analyze on ETAB and bridges. So this is my bridge images. This is analyzed and designed on ETAB. So these are the major application of ETAB. Apart from this, we are talking about the conceptual knowledge of the buildings. So yes, I have one image. Here you can see this is my footing, and the vertical member is my column, and this is horizontal member is my beams, and the panel is my slab. So the load transfer process is from slab to beam, and beam to column, and column to foundation, and foundation to soils. And in my image file I have some special conditions, like this is my basement wall, and this is my strip footing that is connected to the two columns to transfer the load from one column to the other one, and I have a shear walls. So these are the basic nomenclature of the buildings. So I think all the basic concepts are clear. Now we will understand ETAB by L live project of the banquet hall. So this is my architecture file. In the blue solid hedge part is my columns, and this is my beams, and central part is my slab, and the length is 20 feet and width is 10 feet. This is my architecture plan in the X and Y direction, and suppose if you want to see in the 3D view, so I have the Revit file of this architecture plan to understand in an easy way. So this is my vertical member is columns, and this is my beams, and central part is my slabs. So this is 3D view of my banquet hall. So we will analyze this banquet hall. So this is my ETAB home screen, and for starting the new project, click on the new model. When you will click, a dialog box will open in front of us. So just select the third one, options, and select the unit, select the database, and here I'm selecting Indian database, and select the steel design code, that is IS 800, and select the concrete design code, this is IS 456. Click on OK. Now when you will click OK, a dialog box will open in front of us. In this dialog box, it will ask you about the two type of the parameters. First one is the plan, and the second one is the story dimension. So first, to set the plan here, first of all, ETAB basically a software that is used to perform analysis and design in engineering, and it is based on the grid system. So first, you just prepare your grid in the X and Y direction, and draw the grids on the ETAB software. So here I have the two grid in the X and two grid in the Y, and the dimension of the grid in the X and Y is okay. Set current, close. So 5.4, this is my X, this is of 5.4, and this is of 2.7 in the Y. Sorry, number of grid line in the 2 in the X directions, and number of grid line in the Y direction is the 2. The spacing in the X direction, that is of 5.4 and 2.7. Now set the number of stories. Suppose this is my banquet hall and I have the 1 stories, and the story height is the 3 meter, and select the templates. So here I am starting my work with the grid only options. Click on OK. So this is my ETAB home screen, and first, to understand the ETAB software, we will discuss the basic interfaces of the ETAB. So here I have a sheet. In this, you can see this is my main title bar in the top of the sides, and this is my file to help is my menu bars, and this icon, and in the left hand side this is my toolbars. This is my model explorer. This, you can say, this is a tree based work on the tree based system, and this is my display title tab in the active window, and this is also my display title tab in active window. Active or inactive means light blue is my active and this is my inactive. This is my status bar, and this is one story. This is my drawing and selections, and this is my coordinate system, and unit is my current units. So these are the basic interfaces of ETABS software. Now here you will see this is my plan. In this plan I have the two grid line A and B. This is my two grid lines, and 1 and 2 is my two grid line in the y directions, and the spacing is this is 5.4 and this is of 2.7. so this is my banquet hall, and after that, to create the grid lines, we just set the properties. So first of all, go to the define and select the material property option and modify this to this property. Apart from this, you can add your new materials. So first you select your country, this is my India, and select this is my concrete, and grade is M20. Click on OK, and again OK. Here you can see I have a one property in my dialog box, and OK. Second, set the parameter cross section of the beams and columns. So select the frame sections and concrete beam, modify, and this is, suppose this is my beam, and size of the beam is 450 by 230 mm, and select the material. This is my material is M20, and this is of 450 by 230. This is my view of this beam, and select the reinforcement parameters, OK, and click on OK. Here you can see I have a one beam property in my bucket of the frame and frame properties. Click on OK. Again set the column properties. So you can add the new property, and this is my concrete, and suppose I have this is of my columns 300 by 450. This is my size of the columns, and M20, and this is of depth is 450 and width is 300. So this is my preview of columns, and select the reinforcement M20, OK. Click on OK and OK. So this is my column property is defined in my dialog box, and OK. Same, I have defined the column property, beam property. Next is the slab. So go to the define and slab sections, modify, and this is my slab M20, and suppose depth of the slab is 125 mm. OK. So I have defined all the parameters of buildings. Now draw the object on this grid lines. So in the left hand side I have the different type of the tools. So first I will use the beam tools to make a beam frame. So making a selection box around the grid lines. And in the 3D view you can see when I will complete I have the beams around the grid lines by making a selection box. Same, this is the one method to create a beam. So first we set the properties and then we draw the beam object. So first click on the beam. So here you can see first I am just drawing my beams. Okay, so first click on the beam tool, select the property of the beams that is defined 450 by 230, and you have the two type of the options, individual click, making a selection box, and when you making a selection box on the plan, proportionally you can check the 3D view. Now again draw the columns, select the column options and select the column property that is of column 300 by 450, and here I have the columns. You can check, this is your columns, 4 columns at the corners. So this is my columns, and proportionally you can see when I will click this intersections, my column is created in the 3D view. Now I have drawn the columns and beams. Now I will draw the slabs. So here I have the different type of the options to making a slab. So I will use the second one options, draw a rectangular slab, and click the slab options. So first you just select the slab. Yes, so this is my slab, and so here you can check out the view of slab. So this is your 3D view of this particular object. Now assign the supports. So first of all, you just use, first click on the plan view and go to the downward by the move arrow key, and select the joints where you want to apply your supports, and select the assign joint and restraint, and select the first one. This is your fixed supports, apply and OK. Here you can see this is your fixed support is assigned on your buildings. Now third step is load. So for defining of the load, you just select, suppose this is my, this object have the two type of the load, primary load case, dead load and live loads. So first, to define the nomenclature of the load, go to the load patterns, and by default I have the two type of the load, dead load and live load. So click on OK, and suppose I have the sulfate and bowl load in the dead load. So first self-weight is assigned by default on this object. So for defining the wall load from this point to this point, and load of the wall is minus 12 kilonewton per meter. So suppose I have 3 meter height of wall and calculate the load of wall. So this is my length and this is my width and this is my height. So length is per running, that is the 1, and suppose my width is 9 inches. Suppose this is 9 inches my width and height is 3 meter. So value is and density. So suppose this multiply by this multiply by this, and density is density of wall, it is of 20. So final value is this value multiply by this 13.8. So go to the E tab, select the beams where you want to apply your load and assign frame load and distribute it. So this is my 13.8, apply and OK. Now here you can see I have the 13.8 kilonewton per meter wall load on my this beam. Same you can apply the floor load. So first you select the floor, go to the assign and uniform, and suppose this is my 3 kilonewton per meter square is my slab load, the dead, and other one is the my line load. So you can use the line load code. So I am showing you this is my line load code. So you just open the code and this is IS 875 part 2 is my line load, and in this I have the different type of the buildings like residential, commercial buildings. You take the value from the line loads. So suppose this is my rooms, so I have the values 2 kilonewton per meter square. So select assign shell and uniform, and this is my line load and this is suppose 2 kilonewton line and OK. So on this panel I have the two type of the loads. 3 kilonewton is my dead load and 2 kilonewton per meter square is slab load. Now I have done all the activity. So analysis and the run analysis, and save your file where you want to save your file. This is suppose 1 2 and So this is my deformed shape of the buildings after the analysis. Now analysis part is done. The next step is design, and go to the concrete frame design and start and design checks. So for going before, we can first start the design checks. Users check the analysis results. So here we will check the analysis results like bending moment diagrams and shear diagrams. So suppose I want to check the bending moment diagrams and shear force diagrams of this particular frame. So moment 33 apply, so and OK, and click the 3D views. So this is my bending moment diagrams of this particular beams. Here I have the tensions, and the bottoms I have the tensions, and the ends I have the tensions, and by the help of the cursor you check the value of the bending moment and at any other points. Similarly, you can check the shear forces of this particular object. So here I have the maximum shear, and here I have the maximum shear, and at the ends I have only 0 shears. So you can check the analysis by the help of shortcut F8 command. After you verify all the analysis result, you just start the designing part. So first go to the design menu and start the concrete frame design and start design check. After the design, here you can see the reinforcement of the area of this particular beams. This is 391 mm square. I have the required area of the beams 391 and 391, and you can check the design display informations. What is the ratio, longitudinal reinforcement, PM interactions ratios, and rebar percentage. So that's why ETABS is more advanced to comparison to ETABS of CAD softwares. I have the different type of the options, like you can check the column beam capacity ratios. Suppose I'm just click on OK, and you can check the ratios, PM interactions ratios. You can also check out here. So this is the benefit of the ETABS, and you can check the, suppose if you want to check the results of this particular beam, so here you can create your reports by the help of the summary options. So here you can see this is ETABS 2015 concrete frame design and IS 456-2000, and here you can check the different type of the parameters of this particular beams. Apart from this, you can prepare the design detailing parts. Suppose first you go to the detailing and click on the start detailing. Now here you can see this is floor framing plan. When I have done the detailing parts, it will prepare all the drawings related to the this particular project. So this is my floor framing plans. This is 2C B2S1, 2 number concrete beam, and S1 is the marking number, span 1. So this is drawing sheets, so you can set the cover notes, general notes, list of the drawings. So this is the basic arrangement of the drawings, and concrete column schedules. Here you can see this is my column sections, and this is the reinforcement I have required, and this is the rings as per the zones, and this is your title bar, where you can set the information of the project, who is the engineer of this project, and who is the consultant, who is the client of, and your drawing title also. And you can check the concrete beam schedule and concrete column layout. And apart from this, you can check the case views of the columns. So this is your case view. You can explain in a very easy way to any other contractor. And this is my beam case. Yes. So this is my main reinforcement, and this is my rings, and this is my bands. Okay, and this is my columns reinforcements. So you can do the detailing part in a very easy way by the help of ETABS softwares. I hope you understand the basic overall of this ETABS software.